This is the last lecture of this series where we are actually discussing about the heart failure data set. And in this particular video, we are going to discuss about joint plot, like how we can actually find the correlation between all the columns that we are having. Like in this particular case, we are having 7 columns in the category in the numeric type where we can find the correlation. So 7 by 7. So we are going to make a total of 49 graphs. How we are going to make that 49 graph, how we are going to analyze those 49 graphs, that is a question we are going to answer. So let's jump into it and I'll see you on the other side. So we have discussed about a lot of things, so let's discuss about the last step that we are having in EDA. But before that, let me summarize what we have done. We are loading the data. To do the ADA, we are having two types of column. We can have the numeric, where we are having numbers, we are having categorical. Okay, so first of all, we have discussed how we can perform EDA on distribution plot, using distribution plot on numeric ones. So we are taking cholesterol, resting BP, age, and max HR. Then we have performed it on categorical one, like sex. We are having resting ECG, pain type, heart disease, and ST slope. Okay, once we have all those things, we have also performed the violin plot, where we can take pairs and after that do the distribution. Okay, and from here we have analyzed multiple things, and then at the end we have discussed about the correlation. Okay, from the correlation we have found some very interesting points. That is, there are some of the column that are correlated. Okay, if I'm talking about negative -0.4 correlation, so we are having this column, age and max HR. In age and max HR we are having correlation. Okay, so let's see if that correlation is also actually there or not. How to see that? For that purpose, I'm using one of the plot that I'm using is joint plot. So I'm writing SNS dot joint plot. Once I've written this, then I need to define what I need to add in the x-axis. In x-axis, I want to add age, and in the y-axis, I want to add maximum HR. Okay, once that is done, because here I have not defined the data frame, so I also need to define the data should be data frame. Okay, and so far, just execute it. And from here you can see this is the distribution of age based on max HR. Here age is this one, okay, and max HR is this one. And from here we can see the graph is starting from here and go towards this side. Okay, and because it is toward this side, and that is the only way to which it is showing you, okay, this is having some correlation. Okay, if I'm doing the same but with some other one where I'm having almost zero correlation, let's change age and age. What is the correlation? It will take some time. So in age and age we are having totally perfect correlation, because if the age changes, obviously we are having some other column which the same age, obviously they are having 100% correlation. That is why they are on the right side. Okay, if I am taking some of the column where I'm having almost zero correlation, like this one I'm having, so let's take uh, this one, between heart disease and old peak. Let's take these one. Okay, so let's take heart disease and old peak. If I am doing on this, obviously I'll have a spelling mistake. Old peak, that is okay. This is heart disease is okay. Old peak is okay. So what is the problem? Heart this is okay. I need to check the column name then. Okay, so P is smaller. I think that is the issue. Yes, now it is plotting the graph. So from here you can see there's almost no correlation between both of them, because heart disease is zeros and ones, and old peak is a continuous value. Okay, so obviously there is almost no correlation. And let's take uh, cholesterol with it, because this is for that purpose I know that this is having a continuous value. Let's take cholesterol with this. So this is the correlation, and here you can see it's almost random, no correlation is there. From here we can see some correlation. Okay, and let's see how we can actually verify if there is a correlation or not. For that purpose, actually in this graph as well, we can do different kind of plot, different kind of visualization changes. Okay, for example, if I'm writing the kind of graph should be a hexagon. Okay, so it will make hexagons. Okay, from here you can analyze it. Okay, it is starting from the top left and it is going towards the top right. From here you can also see the graph of age distribution, and here you can see the graph of maximum HR. So this is where, in this particular area, where the whole data converges. Okay, because here we are having the darkest points. So this is where the data converges between maximum HR and age, maximum heart rate and age. This is when the people are having maximum heart rate. Okay. Now, what if I want to see actual correlation between them? So to see the correlation, I'm going to draw a regression line. Okay, I am going to draw a regression line. How I can draw a regression line and what is a regression line? For that purpose, I am defining kind is equals to reg. Okay, let's define kind is equals to reg. If I'm executing this, so this will draw an actual regression line, how the data is flowing based on age, how max HR is changing. So this is the best fit line that model has drawn, this one. Okay, and through this best fit line, from here we can analyze if the age increases. If the age increases, so the maximum heart rate will decrease. From this data set we have analyzed it. Okay, same kind of things we can perform on some other plots as well. Some other factors or some other columns we can take, like what are the other things where we are having. So we are having, let's take this darker one between heart disease and max HR. Heart disease and max HR. Okay, we have done it. So let's do it with cholesterol and fasting BS. Okay, can we do it for cholesterol and fast BS? For that purpose, obviously you need to plot the graph first. So it would be cholesterol and fast BS. So in fast BS we are just having 2 to 3 columns, so that might not give you that good correlation because here we are having a number, but let's give it a try. Otherwise we'll take another number as well. So if I'm drawing a regression line, so this is how the regression line fits, but this is not how it should fit, because some of the data is at the top, some of the data is at the bottom. Here the line doesn't fit the data. That is why there is no correlation. Okay, and here we can find the correlation because here we can see the data is the line is flowing through the data. Okay, and let's take the last correlation that we can say. Let's take heart disease and max HR. Heart disease along with max HR. So from here also you can see this, at least this is flowing through the data, because if we are comparing the heart disease, because like here we are having either 0 value of heart disease or 1 value of heart disease. If the heart disease value is 0, means if the person is not having a heart disease, here the density is at the top. Here we can see the density. Okay, and here you can see we are having lesser number of value, here we are having more number of value. This is where the density lies. Okay, if the person is having the heart disease, so the density lies here. Okay, means the maximum heart rate somewhat impact the heart disease. Okay, so this is how we are plotting the pairs, like in two pairs how we can plot the graphs. Now next we are also having something called as joint plot, where we can pair plot, sorry, where we can uh, do all the plots in one line only. Okay, and after that we can analyze each and every plot, and that would be better, because uh, every time you are not going to do all the permutation and combination about the graphs. Okay, age and resting bp, age and cholesterol, age and fasting, you are not going to write the code for displaying each and every plot. How you can do all the things with just one line of code, that is something we are going to do in the next video. So I'm hoping you are clear with the concept how we can plot the joint plot, where we are having all the possible graphs, how we can find the correlation between them, and how we can see which graph we should take, and what is the insight that I can find from those particular data sets or plots. If you're still having any doubt, please let me know. Otherwise, I'll see you in the next video. Bye.